I'm Timothy O'Brien.
I'm Robert Canagator.
I'm Jaden Even.
I'm Matthew Benson.
And we are the Space Garden team, also known as the Space Hydroponics Initiative team. This is our video. Thank you.
The main goal of our project was to support a solution that would be used to grow plants in a lunar simulant. Along with this, we would write a comparison paper for the challenge. Our personal goals was to fully automate the watering process for the plants, and to incorporate a high-pressure aeroponic system.
So why would someone want our project? Well, for NASA, that's simple. For them to have extended missions on celestial bodies, they need a way to produce food for the crew. With our space garden, not only do they have that food source, but they also save a lot of space aboard the rocket, as they do not need to bring enough dehydrated food for subsistence over the duration of the mission. When you think of an astronaut's food, you think of freeze-dried or dehydrated foods. With our project, we want to change the quality of their food to incorporate fresh produce into their diet, which is something we take for granted on Earth, but is a rare treat for someone in space. Going into our constraints, we had a grow area of 6 feet by 8 feet and a height of 8.5 feet. We also needed to incorporate at least 50% of our growth base for the plants to be lunar simulant. As far as power requirements go, we have a max peak of 500 watts, which is way below the maximum allowed of 3,000 watts. Some things that are not constrained are the water consumption, mass, and crew work time per week. However, the smaller we get these values, the better we will do in the competition. With all these constraints, we need to include palatable, safe, and nutritional food with no dependency on resupplies from Earth.
Aeroponics is the practice of growing plants in air without soil. The plants are watered by a fine mist of nutrient solution, as can be seen on the screen now. Our system features a long-lasting high-pressure diaphragm pump, ensuring a reliable fine mist for up to 10 years. To ensure optimal conditions, the amount of nutrients and pH of the water must be monitored and controlled. To accomplish this, 5 roller pumps add nutrients or a pH balancer when needed on a 15-minute loop. This system is self-priming for ease of use. It only needs its intake tubes inserted into the appropriate nutrient or pH solution to work. The ventilation system monitors and controls the heat and airflow of the greenhouse. A servo motor switches between intake and circulation modes based off of ambient conditions around the greenhouse.
Ultimately, our design did work as intended, with the exception of the pump that we chose to use. At first, we thought it was an OEM defect. Later, we came to find out that the pump was not protected from flyback voltage. After we resolved this issue, the group determined that there wasn't time to implement the water level monitoring subsystem. This subsystem was just a stretch goal. All of the primary systems are operational.